Hello and welcome back to Mikey's Flightdeck. Today with the configuration of my Boeing 737 Chrono. You have to configure two devices for your MIP panel, the captain and the first officer side. In this video I will concentrate on the captain's clock. The configuration for the first officer ones is identical. At the beginning we will have a look into my configuration sheet, which you can download for free from my website as a reference, just to see what devices we are dealing with this time. At the beginning you will find all the needed button configurations. All buttons are connected to a multiplexer. Down here is a configuration for the stepper motor, and this stepper motor is written here in red, so this isn't a real Prosim name here. I'm just adding this because I will do a configuration for the stepper motor, but it is not a value directly for this needle that comes from Prosim. We will do it another way. We will come to this later. And when we look more down here, we come to the 7-segment displays, the two drivers. There are 4 configurations for each segment of this clock, I would call it. We will come to this, but these are 2 devices. You have seen this in the construction video here, and these are already all the configurations that are needed. Let's jump to Prosim first to see where we can find all the values that we need. I've opened the Prosim system and display program, and here with a clock for reference. The configurations can be found, like always, under the Config and Configuration tab and in the Combined Config tab. All the configurations are here at the MIP category, and there are over 100 of them. So let's search for Chrono and we will find all the values that we'll need. Here in the MIP sections under switches, there are the 7 buttons around here that we will need. I have already assigned FSU IPC offsets to them, like all buttons I'm configuring. And for the 7-segment displays, we can look at the numerical section here, and up here you will find the values for the 7-segment displays. Prosim is dividing these 2 elements here into 4 sections: upper left, upper right, lower left and lower right, and every section with 2 numbers. And to transmit all these numbers, an 8-bit unsigned offset will be enough. Now I'm moving over to MobiFliight, and there I will show you which devices I have declared for this clock here. You can find this in the MobiFliight modules tab, and at the moment I have only connected my Arduino N, and there are, for example, the multiplexers. I have explained this in one of the last videos, so I think you should know how these are configured. I will use the multiplexer 3, I think, most of the times. Here you can find the 2 stepper motors, N15 to 18 and N26 to 29. 15 to 18 is the stepper motor for the captain's clock. You can see here all the 4 pins, and I have already declared an auto 0 input. This works like a normal button. When it is pushed, then the stepper motor knows that the 0 point is reached, but this button can be connected to a multiplexer like all the other buttons, because at this point here in the modules tab, MobiFliight doesn't know what the different buttons or inputs on the multiplexers do. And so here you can't choose a multiplexer. And so you have to connect this 0 input button directly to the Arduino. This is something you have to keep in mind. And here are the two display drivers here. This driver here for the upper 4 digits and this one for the lower 4 digits. Remember, you can't cascade these drivers like the Max chips, for example, where you can cascade up to, I think, 4 or more in a row. In this case, for the TM1637 driver, you have to connect each of the drivers directly and separate to your Arduino. Let's start with the configuration of the buttons first. When we look again to my configuration sheet, then you can see here the buttons are on the multiplexer 3 and there the inputs 0 up to 7. I have also the nose wheel steering button here in this video. This doesn't belong to the Chrono directly, but it is situated there, and so I will make the configuration here as well. So I have to make configurations N7 up to N14, and I have already written down here the offsets and the bits that I'm using. On the input configuration tab, here you can see I have already done these. Let's have a look into one of these configurations as an example. Go on from the left to the right. I've chosen my Arduino N. The device is my multiplexer 3, and here you can see the input 0. That's the one I'm using for this. If you are a little bit lost with your cabling, then you can also click Scan for Input, and then you can click on the button you want to configure and it will automatically find the right input here. But in this case, I know where it is soldered to. Here, on press, my action type is an FSU IPC offset. Here is the offset you have seen before, and the bit 1 is configured here. Here, on press, I will send the value 1, and on release, I will set the value 0. Here, and this is all what we have to do for all these button configurations. The first time you start MobiFlight, not click the Run button here. When you start MobiFlight and you have made these configurations for the stepper motors, then your stepper motor will turn and will stop at the 0 point. And this is the moment when you can set the needle to the 0 position here on the display. I have done this mostly, but this is the last hardware tricky part, that you have to open this, let the needle run, and then stick the needle on top of the shaft. Here, but when you have managed this and the needle doesn't move anymore, then it should look like this with the needle in the 0 position. But the needle is not now our problem. We will continue with the configuration of the 7-segment displays. For this, I'm here in the Output config tab, and I'm making a new configuration here, N30 to 31, which will be the upper part of the clock here. And the first cool feature I'm seeing, these numbers doesn't come from the simulator. This is my system time, which Prosim shows here. So N30, 31, this is the upper part, and I'm calling this the first configuration of this. So the first 2 digits here. There it is, and into the configuration. The variable is an FSU IPC offset, and the offset is 5360. I'm using the full offset, the full byte, so the size is 1 here, and all the bits are marked. We can already go to the display tab here. It is connected to the Arduino N. It's a display module. Here, the name of the device is the same as my configuration here. The number of digits These are 4 and we are using only the first 2 of them. I will use a left padding with zeros. So when the first digit doesn't come from a Prosim, then it will be replaced by a 0, and then comes the next digit. Let's check the function of the display in general, and for this I'm activating all the displays and transmitting a test value 1, 2, 3, 4 and press test. And here on my webcam hardly, but you can see it, 1, 2, 3, 4. So it is working. I'm deactivating the last 2 digits and it only shows 1 and 2. So this is working here, the top left. And now I'm duplicating this configuration, calling it number 2. And this will be the upper right here, going into the configuration and using a different offset, 5, 3, 6, 1. All the other things will stay the same. And on the display tab, I'm saying use digits 3 and 4. 3 and 4, last test. There we are. Stop it and we're ready to go here. Next, the bottom displays here. Again, I can duplicate this row here, but this time this is called 32, 33. We are now at the next display driver. You remember, every driver has to be connected for its own. So 32 and 33, 1, which means the bottom left display, changing the offset, 5, 3, 6, 2. This is the offset I have declared. There are no official offsets for this. I'm getting this question from time to time. I have chosen this offset by myself. So, and to the display tab. This time I have to switch this here to the next display. And for testing it in general, I'm activating all 4 digits and 1, 2, 3, 4 as our test value. There we are. You can see all the digits are lighted up. Stop it. And because this is the bottom left, only the first 2 will be activated. And again, duplicate this row, call it number 2, and changing the offset for the last time, 5, 3, 6, 3. And on the display tab, I'm using the last 2 digits. Test it. Yes, 1 and 2 in this time. This time only the first 2 digits are transmitted, but this is right. And saying OK. So now MobiFlight knows where the values come from and how it has to show them. It's now time to start up the simulator. Click Run here in MobiFlight and make a test when the values come live from the simulator. The simulator is started and MobiFlight is running, and we can already see the first results. In the background, you can see the values of Prosim system in the MIP tab for a reference, or at the right here you can see them too. So the first line seems to be correct, 22 in the first section and 23 at the top right, but down there we can see 25s, but there shouldn't be any values. When we look here up at the left, you can see the lower left and lower right are getting a -1. And here in MobiFlight, we can see what we get when we have a -1. We get the value 255, and the 55 is the value it is showing here. So after a little bit of thinking and testing, I came out with a solution that can work for this configuration here. My first thought were making a precondition, but a precondition is only making a configuration on or off. It allows a configuration to be fulfilled. But when it hasn't the permission to run, then it doesn't come out that the displays don't illuminate anymore. So we have to find another way to switch them off. And for displays, or 7-segment displays, we have a brightness control. First of all, we will look here to the configuration where we can do the brightness control, and we can make a reference for the brightness. And this reference can be another configuration. So we will need a new configuration for this. Starting here and naming it N3233 var. So the naming is that I know that this configuration has to do with the lower display, and the var says that I'm doing something with this configuration and I shouldn't delete this accidentally. I will assign the same FSU IPC offset like the lower left here. I think this will be enough. So Captain lower left is the 5362, and I will go to the Modify tab and add a comparison modification. When the value is 255, our -1, set it to 0, so lights off. Otherwise, set it to 15, full lights. And now we will use this configuration here for the brightness control. So on the Display tab, we will declare the reference here. Down there, we will find the last configuration we have done and say OK. And you can see the light isn't illuminated anymore. And it seems that we are controlling the brightness of all the 7-segment displays at once. OK. Let's start the timer. It runs. Pausing it. And when we reset it, yeah, it doesn't illuminate anymore. One thing I have forgotten, I think it was hardly visible. When I start the timer, here in Prosim displays, there are 2 dots between the numbers, and maybe you can see between the numbers the 2 dots are missing. So we have to activate them, going into the configuration and say here activate the dot, and there you can see it. There's the dot. And when we stop it and reset it, everything is off. Okay, so let's make another test now that the timer is working. We can also push here the time date button. It's changing from year 2024, there we have it, to day and month 5 and 4. 5 and 4. So this is working. Let's stop. And we're back here at the time. Wow, now I nearly have forgotten one very important configuration of this chrono here. I hope this doesn't confuse you too much, and I hope it will come out good in the video later. The needle here was always in the way, so that I have forgotten there are 2 dots here when the display is showing a time. When it is showing a date, then there aren't these 2 dots. So how can we realize this? Prosim has some gates here for this case. On the left here in Prosim, you can see the Chrono Captain label time gate is activated. When we are activating time date, then this switches from year to a day month, and there aren't these 2 dots here. So stopping this, the time gate is activated again, the dots are there. So we have to find a way to observe the time gate. And when this is activated, then the 2 dots must be shown. So first of all, we activate the dot in our configuration here. At the second place, there should be the dot. Say OK, and yeah, you can see it. There it is on our display. So let's call this configuration dot. To deactivate the dot, we will observe the time gate, which we can find here in config and configuration, and in the combine config tab again, search for Chrono, and here in the MIP section under gate, I have already inserted an offset. I only need 1 bit of an offset to observe the time gate here. And I will create a new configuration. I've called this N39. So this configuration is only used as a variable. Oh, and we're observing the offset 534D and bit 1. And you can see it is activated. It gives us the value 2, but to keep it more simple, only 1 for on and 0 for off. We will make a modification here, make a comparison. If the value is 2, set it to 1, else set it to 0. So now you can see it's on, so the output value is 1, and when we switch to time date, you can see it changes to 0. And this we can now use as a precondition. So we duplicate our dot configuration here and delete the dot. So this will be our configuration without the dot. So and we go to the precondition and use config item, the configuration that I have done now, N39 var. If the value is 0, then this configuration should be activated. And the special thing behind this new configuration is that there isn't a dot. Now it is deactivated. You can see the precondition says this configuration isn't active at the moment, so the 2 dots are there. And now we have to make the same precondition here. Config item, use the same item, but the dot configuration is always active when it is 1. Let's make a test again. Yes. Now when the date is shown, or month and day, then there aren't the dots. And now when we go back to time, then the dot is there. One thing that did cost me a lot of time to understand was the configuration of the needle here, and especially one checkbox, but I will come to this in a moment. I have already prepared the configuration for the stepper motor N15 to 18, and let's have a look into this configuration. The offset is the same that I'm using down here for the lower right 7-segment display, because these are corresponding to each other. And then in the display tab, I've chosen my stepper motor and set the display scale to 60, because we have 60 steps for one full turnaround of the needle. The full revolution for the stepper motor are 2048 steps, and I have reduced the max speed and acceleration. I had some problems during the configuration of my flaps gauge for the motor finding its way back, the 0 position again, and this disappeared when I reduced the speeds, and so I did the same here. Yes, and when we now test it again, then you can see the needle is synchronized with the needle in Prosim displays and also with the seconds down here on the clock. And when we push it, pausing it and reset it, it finds back its 0 position. But this wasn't always the fact here. So let me show you something. Stop MobiFliight and have a look here to the MobiFliight Modules tab. Opening the configuration for the stepper motor, you can see I haven't checked now the box disable stepper when at target position. I have always activated this because I thought this might be a good idea to stop powering the motor when he has reached its position. But let's have a look what happened when we upload this. Click run again. And now start the needle again. At the first try, this seems to be okay. I will now skip some time and let the needle run. You can now hardly see down the clock is at 40 seconds and the needle is somewhere at 38. And when I reset it now, you can see the needle doesn't go back to the normal 0 position. And I wasn't able to get it to the correct position or synchronize it correctly with a clock. And now look at the changes. What happens again when I'm deactivating this checkbox and upload this configuration. It searches again its 0 position, reaches it. And when I run this time the needle is synchronized. I'm skipping again to the time point. So I wasn't able to stop right at the point as I did it last time, but you see it here. 41 seconds and the needle is exactly at 41 seconds. And when I now reset it, it goes back to its 0 position. So I wouldn't have thought that this small checkbox has such a dramatical result here. I think in use cases where the stepper motor should stop for a longer time at a certain position, this might make sense. But in this case here, where it has to start and stop so often, just let the stepper motor powered. Only some last buttons are missing. The set button, yeah, you can see the first digits are blinking on and off. And when I click again, the second pair is blinking. And set again. How have I realized this blinking? This was something I haven't shown you. When we go back now to the configuration for this upper display, there I have made in the Modify tab a comparison. So this blinking on and off, you remember this, an off value gives us a -1 from Prosim, which is 255 in my case. So if the value is 255, then set it to 2 spaces. So I have inverted here space 2 times so that I shift out the numbers. Otherwise, give it the value that comes. So why haven't I chosen the brightness option again like I have done in the lower display? So the reason for this is the brightness option controls the whole displays. So both values would have blinked, but only the first 2 are blinking, or the last 2. And this can be done via the brightness option. And though I have chosen this 2 spaces way, and this works well here. So the plus and minus button can be checked up here in Prosim. There is the Chrono Captain plus and minus. Let's check this. Pushed, yes, and the minus pushed. So these are working. Estimated time here. You can see it shows what it should, and reset. There it is. Here, one last thing for this panel here, the nose wheel steering, and this can be found at the landing gear tab here. And here is the nose wheel steering. It is on normal, and now it is on alternate and normal again. So finally the configuration for the Chrono is done, and you can't imagine how much time it has cost me to find out that this small checkbox was the reason for most of my problems with my needle. I'm showing this to you in such a detail so that you may have an idea where to start searching when something isn't working as it should in your configuration. Again, all the names of the configuration and used offsets can be found in my connection sheet that is available for free in the download section of my website. And if you want to build your own Chrono display or more panels for your 737 cockpit at home, you can find all the needed plans and files in the member section of my website. So I hope we'll see you soon back on the flight deck.